All right, so this week we are going to cover joins. And joins are actually what I think are like kind of the bread and butter of databases, and understanding how they work is really important. So let me share my screen, because the first thing I want to go over, because someone actually asked this, which is really nice, is they asked what what's the why do we separate data into different tables, so on and so forth, which was actually a really good question, um and I'm going to hopefully explain that to you. So what I have here is, I kind of just started setting this up right before the meeting, and I didn't want to get too far because I thought, it'd be good to explain it as we go about it. So what I'm going to do is, I'm just going to, can we hide these? Yep, there we go. Apparently not. Let's see, can we hide these rows? Hide, there we go. We'll just hide those for right now. Because what we want to look at, so what we're typically used to working in is spreadsheets. When we think of a table, when we think of rows and columns, I think it's safe to say that most of us think of spreadsheets, because it's a table, which is 100% accurate. And something that we might be used to seeing is something like this, where we kind of have a data set where we have some information. In this case, we have first name, last name, username. We have email one type, email two type. I have physical address line 1, physical address line 2, mail address line 1, and mail address line 2. And this is great, right? You know, a lot of times, like if you're just trying to kind of get by, this is fine. It works. But what happens when we want to add some more data? What if we want to say, oh, we want to be able to track, when did they add this email? Or when did they move to 1 Bagshot Row, Bag End, Shire, Hobbiton? What if we want to track some additional components? And also, what if someone wants to add another email? And I purposely did this. You'll notice that Gandalf, both of his emails are work. Well, what if we want to let them add more than one email? And we can make this work. We just have to add more emails. But then it gets weird, because what if someone puts email 2 in but not email 1? And what if someone wants 10 email addresses, so on and so forth? So we're going to kind of work through why, and hopefully at the end it makes sense. So we kind of have 3 different components here, or maybe more, but we have people. We kind of have this first name, last name information. That's kind of what I would consider to be one kind of set of data. Then we kind of have this email address stuff. You could kind of isolate that to say, hey, look, this is email related data. And then over here, we have addressing. And those addresses are kind of another little subset of data. So what we're going to do is, we're going to split it out. We're going to split it all out. And so I can show you kind of how it works. And then hopefully it will help you understand how it works, why we want to do it. And then should seg right into joins, because then we're going to talk about joins. So with our little example here, what we're going to do is, we're going to start with our person. And you're going to notice that I'm going to actually add data to our tables, so to speak. And because I think that's one of the benefits of splitting out our data, is that we can add columns really easily versus kind of making it a mess. So I'm going to start with this person table. Start with this person table, and you can see that I've already kind of got a person ID, first name, last name, birth date. I'm going to leave blank. All male. Let's pretend that they're all active. And then created date. Let's say we just started today. Let's throw some stuff in here. Let's say Bilbo was 01/02 of 1995. Bilbo's really old, so he was 05/16 of 1752, because Hobbit age is weird. Gandalf is really old. We really don't even know how old he is, but he's going to tell us. So he's a March guy. Let's say the 14th and 1423. Just making it up. So we kind of have all this, all of our person data here now. So what I'm going to do now is, now we want to kind of take another set of data. So for this example, I'm going to skip some like username. I'm going to put in like email now. Let's create an email table. Come on, bold. There we go. I'm just going to take and copy this because we're going to borrow some of these columns. We're going to have an email ID. We're going to have a person ID, which will be important here in just a minute. We'll talk about it. So let's go ahead and delete that. All right. All right, so our email ID is just going to count up like normal. We're going to need a couple more here. So let's just go like that. All right. Let me get rid of this border. We'll add 6 emails here. So the first thing when we're inserting a record is we want to make sure, because we're kind of splitting this all up, we want to make sure we put in the right data. So let's say we're doing Bilbo Baggins email. So we're going to put that email there for us. All right, so we have Bilbo at the Shire. Now we know that this is Bilbo's email. So this is I guess pop quiz. What column could I use to make sure that Bilbo at the Shire.com ties to Bilbo Baggins in the person table? What column should I put a value in to tie them together? ID, perfect. Yep, we're going to use this person ID because that's kind of what's going to link these together. So if I put a 1 there, now I know that this record right here belongs to person ID 1. So then if we go look at the person table, person ID 1 is Bilbo Baggins. And this is a personal. The start date is, let's say, today, and date is null, private. Since it's a personal email, we're going to put a 1 there. All right, and Bilbo has 2 email addresses, so we're going to put another 1 here because we want this one to be tied to Bilbo as well. And it's bbaggins@lotr.com. And this is a work email. We're going to say that he signed up today, and it is not private. We're going to put a 0 there. I like to use 1s and 0s just because that way it's a binary and it works well with web applications. All right, so there's a Bilbo Baggins email address. So let's do Frodo next. So what should I put for person ID if we're going to do Frodo's email address? What should I put for person ID? Another pop quiz. This one's easy. Feel free to type it in. 2, that's right. Perfect. Yep, we're going to put a 2 in there. So you guys are getting it, which is good. And this is a Frodo at the Shire is personal. And let's say that Frodo doesn't care. He's going to let us share his email with others. And again, we're going to do another Frodo one. And this one's a work one. But let's pretend that he took this off. So let's say he added this one earlier, which I know doesn't make any sense. But let's say this one has an end date. Put that there. And then let's say that he changed his work email to, let's say that he changed his work email to Frodo.Baggins at LOTR. I guess this would be, there we go. All right. And so what the other nice thing about this is we can add some additional data here. So we can see that, oh, Frodo, even though he has three, get out of there, even though he has 3 email addresses tied to him, based on the start date and end date, we can determine which ones are active. So today is May 11th. So what we would look is we would say, hey, what emails for Frodo, for those records, which one have meet the logic that the current date, May 11th, is between or equal to the start date, greater than or equal to the start date, or less than or equal to the end date, which it would just return those two. So you can kind of use the current date to find the active ones, as well as then you have a historical record to say like, oh, when Frodo calls and says, hey, why am I not getting any emails at fbaggins@lotr.com? We can say, hey, on May 10th, you deactivated this email. So then you kind of have a historical record. Because in databases, when we're dealing with data, deleting data is one of the last things that we actually want to do. So let's go ahead and add one of Gandalf's here just for sake of doing it. And he's a pretty private fellow. So we are going to just say that his is private, meaning don't share it. All right. So one thing I want to talk about is this. Let's go ahead and make this kind of pretty here so we can see it. Let's bold it. So one important concept, keywords that I want you to remember is primary key and foreign key. So this is our foreign key. The reason it's foreign is because this is the only piece of data. And I don't know if you saw this on Teams, but someone said, did a quote from the book where it talks about data redundancy. Why do we split data out between a lot of tables? And it is for data redundancy because we don't have to have like email stuff multiple times, all that kind of stuff. We don't have to continually put like first name, last name on all these different tables and have all this data duplication. Because like if I wanted to change Bilbo Baggins' name, we might have this data set that has email and address, but what if we have another one that has their rentals? We probably want their first name and last name if we're doing it by spreadsheet. And so if I have to change Bilbo's name, I have to change it in a bunch of different places. Versus this way, because things tie to it, I can change the first name and last name all I want, and it will update everywhere because that's the only place that this text even exists. But this is our primary key, and let's actually bold this so it kind of stands out. So our primary key for the email table is usually like the name of the table _ ID. You might also see it just be ID. I prefer to have it be the table name, so that way I never get confused about which ID I'm talking about. It's always the table name _ ID. And then the foreign key, like I talked about with data redundancy, the only data that will be redundant in a normalized in an object relational database is the foreign key. And that's because the foreign key, we have to have it to tie these records together. But the nice thing is normally your foreign key is the primary key of the other table. So let's go ahead and add our primary key here. hold that. There we go. And so this primary key will never change. And so when we have a foreign key that references it, it's a perfect match, so to speak. It makes it nice and easy. Does that make sense to everybody? Primary key, foreign key concept.
Yes.
Okay.
I have a question about that real quick.
Sure.
Do primary keys always have to be like incrementing in value, kind of like numbers do, or if it was maybe hexadecimal as well, or could it be something kind of, I don't know, more of a name of something?
You could, like it's possible, but there are limitations as far as like efficiency
Okay.
and stuff like that. And then the other problem is once we make that a primary key, we have to guarantee uniqueness. And so like a lot of times like the name's fine. So like, if we're talking, depending on what we're talking about, there are certainly names that are unique, but there's other ways around that. Most of the time, while you can do it, most of the time it's highly, highly, highly recommended to use either an integer, like what we kind of show in most cases, or if you get into bigger databases, you use like GUID type things, which are a string. But like I said, there's compromises for that, like you get more keys, but there are you get more numbers possible that you can have, but there are limitations also on efficiency side.
Okay. All right. Thanks.
But when we'll get there, and so for example, like we probably don't want email more than once, or like a username. There are certainly times where we would want the primary key, or not the primary key, we would want a column to be unique. And we can add that constraint after the fact. So primary key is not the only one that can be unique. We can make any column, we can make a combination of columns unique. So that way it can be nice and normalized and clean. All right, and I'm going to show you the address table just so we can, and this is more, I want to kind of show you more for if you're doing the final project. I kind of want to just show one more little design concept that can be interesting. So let's do address type. I'm going to do an address type table. And in this case, I'm going to put, let's just copy this whole thing here. Address type ID. And let's see if we can clear formatting. All right, so let's build some address types. So and in this case, it might be kind of small. I'm just going to kind of do 1, 2, and 3. So we're going to have a work. Let's do home. Physical. Oh, you know what? Let's add one column. And in fact, I'm just going to change this one. We're going to change this to now we're going to have to add some anyways. Right. All right, and I'm kind of thinking through this as we go here. You know what, let's take this off. Sorry. We're going to go back to the original. There. So let's do home. Let's just do 2 for now. Well, let's do another one. Let's do school. All right. So basically, this table is just going to hold types of address. And this is something that users are never really going to have control over. This is something that we would kind of manage from an admin side. But the nice thing is that we can then control the address table and options that are available there. Let's clear this formatting as well. Oh, all right, so address ID. We're going to add some columns here. In fact, let's just grab some from right here. Right. Put them right there. All right, let's put a person ID here. Perfect. And we are also going to maybe add 2. We're going to add physical. All right. Let's do, yep, address line 1. Normally we'd kind of do something a little different here, but we're going to just roll with it here. All right. So basically what we have here is we have our address table, and we're going to, oh, you know what? We forgot one more. Go ahead and scoot these over, and we're going to call this address type ID. All right. This table has 2 foreign keys. The first one is for person. The second one is for our address type ID. So let's say we're going to add a home address for Bilbo Baggins. And when I mean physical, I'm really talking about a flag. So just to make that better. So like this could be like a checkbox on the web form. So let's say that it is a physical address, and let's say that he does get mail there. And then we can add that address, which I actually looked it up. He does have an address. All right. And normally, so like up there, just to kind of make it cleaner, I put all this together. So I had like address line 1, address line 2. But really what we'd want is we'd kind of want like a street address number or street address. Line 2, city, state, and then probably a zip. All right. So, and based on this, his city is technically it's Shire. I think Bag End is the name of his like house. So we'll just put that. I don't think they have zip codes in the Shire, but we're going to put one there anyways. So we have, we just added a row for him, and we could do the same thing for others. But I think you guys get the point. I don't want to go too much, but the main concept here is that we can add tables that kind of control these ones. So this might be a drop-down menu. And we could actually simulate this by kind of saying, let's see, I think we can say format as a
Drop down is data validation. So that's what you're looking for.
Yep, there we go. I think I did that wrong. There we go. All right, yeah, so we can kind of simulate this in a way to say, like, you know, if we were on like a website and you're typing in your address, these are the options that you would have. And on the website, we can even build in logic to say, oh, only show options if active is equal to 1, which these all are. But let's say all of a sudden we say, oh, the boss came to us and said, we don't want to record school addresses anymore because there's a liability or blah, blah, blah. We can just turn that off and people won't be able to sign up with their school address anymore. So that's why it's kind of nice. Another version of this, you can think of like a credit card type table where you could do something similar. Or if we want to add an option, we don't have to do any programming to add an option. We can just add an option to our database. And then when users go in to sign up, they can just click, choose it from the dropdown, and it ties it all together on the back end. Because realistically in the table, when we select home, it's really going to be a 1. We just kind of put the name and the code next to it so we can work with it and make it pretty and easier for the user. All right, does anyone have any questions about this before we move on to actually using SQL? All righty. Yeah, and hopefully this helps kind of, if you're still kind of putting your final project together, hopefully this kind of gives you some ideas how you can kind of tie some stuff together if you're going to do something like that. All right. Let's write some SQL. So joins. I showed you how we're going to create multiple tables. We talked about primary key and foreign key, and how we can relate tables together, just like what we did last week. If you were there, we kind of real quick threw together some tables for my final project, where we did the same thing. You know, we had our tables tied together with primary keys and foreign keys. And you can see those relationships. And the nice thing is, like what was asked, is we do that to isolate data so that we don't have any redundancy, because if we ever want to use data from somewhere else, we can just connect to it if that connection exists. That's why we want to build those connections. And so what I'm going to show you now is how to utilize those connections in our select statements. So let me get my local host pulled up here, and my cursor is broken, it looks like. So let's just do a new script here. And we are going to use Sakila. All right. I'm actually going to pull you over here. Right there. This just a little bit. I'm going to log in here as well. All right. Show tables. There we go. We have our list of tables. Very similar. I like to pull up this because then I can really quick check some definitions if we need it. All right, so what we're going to do is we're going to kind of use a similar thing. So if we look at our tables in Sakila, you notice we have customer. We also have address. Might look a little familiar in some others. So we're going to use that same kind of deal. we're going to kind of pull a lot of the same information. So let's start off with customer. That's kind of our main focus here. So I'm going to select everything from customer. All right, let's describe customer over here so we can take a look. All right, so we can see we have a customer ID, store ID. Our email is in here. You'll notice that they do this a little different. So we have address ID inside of our customer table. So if we were to run this ERD, which, let's just do that real quick. So I'm going to do a new ER diagram for our local host, Aquila. All right, so if we take a look at this is why these are nice. Is let's pull some of these out here out of the way, because really what we want to see is the way that our customer is related to our address. It's really kind of gross. Let's pull this down here and see if we can get, because I think we're doing a loopy thing. There we go. Kind of an odd little line, but we get the picture. So anyways, there's our address connection. So we can see that those two are directly related. And in this case, it's a kind of like a one-to-one, a one-to-many relationship. But basically we have customer, because customer has address ID in it versus the other way around. A customer can really only have one address at a time. But what's interesting here is because address is utilized by other things, such as store and staff. You can see that staff has an address ID, store has an address ID. And so what's nice is all of our addresses are all in the same place, which is one of those things that you kind of got to decide how you're going to do it and what your business needs are. So in this case, the developers of this particular piece of software decided, hey, a customer, we don't care about historical address tracking. We just need a customer to have an address, and we want them all in the same place, which is fine. So we're going to start with a customer, have our stuff here, and we're going to call this C. So this is called a table alias. And basically you can put a space and then type any word after it to kind of rename it or give it a nickname. And in this case, I like to keep mine short, usually either one character or, just something to remember it by, something that's easy to notice. But I'm just going to keep mine to one letter for right now. So I'm going to say select everything from customer C. And then this is where we're going to do our join. So what we want to do is we want to connect to address. And we have a couple different options here. And I am a big fan of inner join, but it really just depends on what you want to do. And in this case, the inner join, it's only going to find matches. And it's always good to explore your data. So I'm going to select select the distinct value of address ID, where address ID, we need a from customer, where address ID is null. Let's just see if there's any nulls in here. And there's no nulls, so we know an inner join is fine because we're not going to drop any anyways. So we're going to inner join to address. I'm going to call that A. Now we have to tell it what we want to match on. And this is where that primary key, foreign key comes in handy. So in this case, we want, what's the column? And I guess I'll let you guys answer this. Looking here, what's the column in customer that we would use to connect to address? Which one in customer is the foreign key that we would use to connect to address? Go ahead and type it in the chat if you want. All right. Yep, it would be the address ID. So we're gonna go from contact or customer dot address ID. And the on clause, we're basically saying, okay, what columns or which column, it can be one or many, are we going to match on? So now let's take a look at our address table. And we can see an address, we have address ID. And that's where it's good to know your data. That's why I like to pull up the ERD, because it's very easy to say, hey, you know, we want to get from customer to address. Oh, there it is. Which fields are that? Oh, address ID and address ID. So that's why those ERDs are really nice. So then we're going to go from address dot address ID is our destination. So as long as those two match, we know we're connecting our rows properly.
Is it common to see the things that you connect like that are not named the same thing, like address ID equals address ID? I know there's a C and an A for the two different tables, but would it ever be C dot something equals A dot something different?
It could. And that's why when you build your databases, when you plan your column names, that's why there's a kind of a strict uniform way that kind of people do things. Because I might build this massive database and then hand it off to someone else, and you can imagine how difficult that would be if this was like A dot address ID is equal to C dot home, you know, or something like that.
Yeah.
So that's why we try to keep things as uniform as possible. And you know, the more simple you keep it, the better. Because like I'm sure you guys know about WordPress. The way WordPress kind of structures theirs is like, if we want to go from a post ID to post meta, like their post table is something like this. And which I don't agree with, and I blame it on web developers kind of scrapping it together, but that's for another day.
Okay.
But anyways, this is kind of how they do it. They go PID equals M dot post ID, which I get where they come from. So this is probably the acceptable worst case scenario, the way I kind of like to look at it. And the reason they do that is because it does save you keystrokes, right? Like when they're doing their stuff, ID is it's safe to assume that, oh, the ID in the post table belongs to post. I can see where they would say, oh, it's redundant to put it in there. But the reason why I prefer it is just because when you're looking at it like this, like if we wanted, like, for example, let's say we just want to select the ID from post, the ID from meta, all of a sudden now you kind of have these two column names, and depending on what you're doing, what it looks like, it could get confusing. And so that's why I like to actually just put table name underscore ID, because that way, whenever I'm like evaluating, like, oh, am I doing my query right? It's really easy to say, am I joining on the same two columns? Because I want it to be the same column, just different table names. Because one of my biggest mistakes that I often do is I'll actually type like this just because my brain's going fast, and I'll do something like that. And then it becomes very, very easy to catch.
Okay. Thanks.
Yep. All right. So once we have our inner join written, we have our on clause to kind of say, how do we want to match these? And we can run this. And now we have all of our people tied to our locations. So you can see we have our cities and yada, yada. So let's make this a little cleaner, because I don't want to just select everything. So let's get a C dot first name, C dot last name, and let's get A dot address. So let's run that. And there we go. Now we have our data from customer, and our data from address. And when you do your, once we give these aliases, you'll want to put those aliases in front. And just to kind of show you what those aliases do, why we use them, is because otherwise we would have to use the full table name. Which you're more than welcome to do if you, I guess, want to really practice your keystrokes. But I wouldn't recommend it. So essentially what we're doing with the aliases is we're shortening this so we don't have to type as much. Because you can see we get the same result. The only difference is we've kind of given these ones nicknames to make it easier to type. Because we're going to take this another step further, because let's say we want, we have their address, but let's say we want their city and their state. But if we look in the address table, we don't have a city, we have a city ID. And so then we're like, okay, well, I want the city name. So we have to go get that. And so let's do another join. And one thing I want to point out is at this point, this is now a table. I like to think of it as a table. Anytime you do a join, the next time you join, it's like this little section here is already a table. Even the columns that don't show, it's all there. So whenever you do your join, you're joining off the result of the first one. So let's do another inner join to city. And I'm just going to call this one city. And we're going to go where on, because we want to match. And in this case, we're going to go from address. It's kind of like a path, right? We have to draw our lines. If we go back to our ERD, we have address here, and we want to go, we started a customer, and based on address ID, we got to address. Well, now we want to go to city. And so we use address city ID and city ID. All right, so let's add our city dot, and this is where we can kind of add our new columns here. All right, so there's our city. What else do we got in city? Let's describe city, because what if we want, we have our country ID. So we want the country too. So we go to our country, and oh, now our country, we want the country name, not the ID. So we just describe country, and we see it there, so we can join. And I'm going to call this one CO. We're going to go from city country ID to country.country ID. So you can see how we're kind of building this path, and we keep going and going and going to get to the data we need. And there we go. So now we have our, we actually have data from 4 different tables: customer, address, city, and country, which is kind of neat. And then Jandy asked, I noticed we could use a select statement as a table to join from to, and that is correct. So a great example of this, I mean, and there's lots of ways to kind of skin the cat, if you will. But one of the things that's kind of nice is when we're doing aggregation. So let's say that we wanted to get yeah, we could join a lot of things. Let's say we want to take this and now we want to join. There's a good example. Let's say we want the count of people by city and country. We have our city, we have our country. We want to do a count of customers. We want to make sure we don't count them twice. Not that we should, but just make sure we're going to count distinct customer IDs as We're going to call that customer count. And since we're doing aggregation, we need a group by clause. And we're just going to add our two first columns. So because we want the count of customers by city and country. So we just add that. Go ahead and run. And it looks like most of them are 1. We do have a couple in 2. So let's actually take city out of it. Let's say we just want a count of our customers by country. We want to know which country is the most important, right? So there we go. We have the count of our customers by country, and let's order by to descending because we want the highest first. So we can see that India, China, and then United States are kind of our top 3. So then, based on this data, we could make some strategic business decisions about that and so on and so forth. But then let's say that, what do we have in customer? We have create a date. Okay, so then let's say we want to know, okay, I want to know how many people were added in each country by the date they were added, right? We want to see like use customer acquisition by month. So in this case, what we could do is we could do a subquery and do a lot of other things. So we have our select statement here. Right, so there's our select statement. We have our country. So we could, and this wouldn't necessarily be a join. I'm trying to think of a way we could join. Let me back up. That's not a good example for a join. Okay, we have our customer count. Oh, here's a good example. Let's say now, not only do we want our customer count, but we also want to see our revenue by country. So let's take a look at we could take this and there is by far an easier way to do this, but we're just not going to do it right now. So we're going to inner join, but instead of putting a table, we're going to do a subquery. And in this case, let's say select the sum. Oh, we want the country ID. So we want co.country ID. And we want the sum. I think this is in a rental table. What tables do we got here? We have sales by store. Let's do sales by store. That's a great one. Make sure it is what we think. Aha, there we go, total sales. All right, so let's we're gonna take the sum of total sales. I'm gonna call that total revenue. And where are we getting that from? Well, we just saw the first one. And there's a couple ways we can do this. We can go backwards, or we can go frontwards, or we can kind of start wherever. I'm going to work this one a little backwards. So I'm going to start sales by store. And that's actually a view, which is interesting. Where's the actual scribe payment? We'll just use the view. That's fine. Actually, yeah, let's just use the V. Now let's do it the right way. Let's do it the right way. So we're going to say from payment P, inner join. And so on this one, we're going to have to go from payment to rental, because I think rental has a date, customer ID. Yep. Actually, we want store.
Brother Cook.
Yep.
Don't forget to change the name of the sum. You have the total sales from the
Oh, yes,
payment.
thank you.
You're welcome.
Yep, because that would change to amount to match our payment. All right, so what we're going to do is we're going to say, well, we want it by, since we're looking at customers, customer count, we're going to go actually to the customer. So if we take a look at payment again, we're going to go from payment to customer ID. So we're going to say from payment P, interjoin customer C on P dot customer ID is equal to C dot customer ID. And then we're going to go from customer to address on C dot address ID is equal to A dot address ID. And then we're going to go from address to city. And then we're going to go from city to country. On city dot country ID is equal to country dot country ID. All right. And what's nice about subqueries is we're actually going to take this and we're going to run it all by its lonesome here for a minute so we can make sure we get it. So we have all this done. We need our group by co dot country ID. Oh, and it looks like unknown column co dot country ID. Oh, I forgot to give this an alias. There we go. In on clause. There we go. Those aliases, got to make sure they match. Oh, country. There we go. So now we have the sum of our revenue by country ID, but we don't want country ID. We just want country. Okay, now we're going to change that in a minute. All right. So now we can see our country and the total revenue. So now what I'm going to do is I'm going to take, I'm actually going to copy this and we're going to put it back up in our little embedded select here. And you notice that before we were selecting it based on the country ID, we're going to do that again. And I'll show you why in just a second. So we have to change it in the select list and the group by. And the reason we want country ID is so we have something to join on. Because if we had the country name, you know, we could match on it, but again, we want to try to only match on keys because those are the only guaranteed ones. We could match on the country name, but like I said, it's not guaranteed. And when you're, you know, let's pretend that this data is for the board of directors. We want to make sure it's as accurate as possible. So we have our little select statement here that's going to act as a table. So we're going to call it rev. So our inner join, we're taking what we had done before. We're going to inner join that to our little rev table based on co.country ID is equal to rev.country ID. And we want to rename this country ID. There we go. Technically, I think it'll work, but we've got it. The reason I rename this is so that we can connect it. Because you'll notice that I gave this kind of an alias of rev. And so that way, when we connect it, we go from co.country ID, which is actually up here, to rev.country ID, because everything in this select statement is isolated. So this query right here and below it, it doesn't know about any of this in here. All it knows is, hey, I know that there's a table called rev and it has country ID and total revenue. So we're actually going to add our total revenue here. Let's actually the first rev.total rev. And the reason I'm putting it first is because it's already aggregated. Let's try it. Oh, I guess it helps not to end the SQL statement inside. Let's try that again. There we go. So now we have our total revenue and our customer count. And we did that with an inner join to a subquery that's acting as a table. And this is pretty advanced, so you don't need to be too worried if you're like, oh, I couldn't write that off the top of my head. That's fine, because this is kind of a hack job anyways. There's definitely an easier way to get this same data, but I just wanted to show that it's possible. Because basically we can write subqueries and give it an alias, just like we do other tables, and it kind of acts like a little table. And we know exactly what that table is going to look like because we can run it and see. So when we use this, this is what that table is going to look like. So we can pretend this is a table and, oh, we want to join on country ID and get the total revenue. All right. Cool, cool. Does that make sense? Somewhat sense to everybody?
Yes.
Perfect. I'm going to format this just a little bit, so hopefully it makes a little bit more sense. I kind of like to keep my subqueries kind of like that. That way it's nice and easy to see that it's a little separate. All right, so in all these we used inner join, but one thing I want to talk about is the difference between an inner join and a left join and right join and all those other ones. So if you do a Google search for SQL joins, an image search, there is this nice little chart that has been my go-to forever. In fact, when I was taking my SQL certifications, I would actually, when I was just beginning, you know, I kind of, you know, I had them all committed to memory, but I would draw these to kind of help me figure out what's going on. Because when I was doing my certifications, a lot of times it says how many rows are going to be in the result set, and you have to know based on the join. And because each one of these kind of do a different thing. And I think we might have gone over this, I can't remember, but we'll go over it again anyways. But in this case, what these Venn diagrams do is each one of these circles is a table, and the colored portion are the rows from that table that get returned to us. If it's white, that means that they were dropped. They were excluded from the query. So in our case, we were using all inner joins, which is right in the middle because it is it's probably one of the more popular ones just because of what it does. So you can see that an inner join will return matches from both tables, which realistically, like a good percentage of the time, probably I would say in my work, probably it's like 70%. You want there to be matches, especially if you're joining on primary foreign key that are not null. Like if the foreign key is not null, then you want to use an inner join because that way your query works the same logic as what you're expecting, meaning I don't want any people who don't have an address, or like in this case, do we want to include countries that don't have customers? Which in this case, we probably would. So, you know, we used an inner join because like I know that it's all there, but let's say a country didn't have a customer and we want to show that country having 0 customers rather than just leave it off, especially if we're calculating like averages and stuff like that. Because we would want to say like, you know, we would want to calculate that, oh, that country doesn't have any in it rather than exclude it. So that's when the left join comes in because and it all depends on ordering. So you'll notice that this is a left join, this is a right join, they're opposite, but it just depends on which way we're doing it. So in our case, we go from customer to country. And in that case, we would actually want to use a right join because we don't care if all of the customers are there, but we want to make sure that regardless of whether or not they have a customer, table B, which in our case would be like address, city, country. We want to make sure that they're all there. And I usually write my SQL statements to use left joins. So like if I were going to rewrite that one, actually, you know, because I'm trying to say, hey, I want all the countries, whether or not they have a customer or not, I would start like this. So we're going to get the co.country from country co left join. And in this case, we know that we have to get to city. We know that all cities have a country. Do all countries have a city? That's something I don't know. So let's just use a left join city, just in case. The country ID is equal to city country ID. So I like to kind of start with the origin of the data because that way the left joins make sense, because we want all the countries regardless of whether or not they have a city and whether or not they have a customer living there. So we're going to left join on address on city.city ID is equal to a dot city ID. And then we're going to left join again to customer C on a dot address ID is equal to C dot address ID. All right, so you'll notice that I did left joins all the way through. And that's because if I put an inner join here, remember it joins off all of the previous result set. If I did an inner join here, I would only get countries, cities, and addresses that have a customer. So basically, once we've gotten here, it works as a singular table. So I do left joins all the way through to make sure that we're good. And then I do my count distinct c.customer ID as total customers. Then let's add our group by co.country. There's our total customers. So that's kind of this way we'll get all the countries whether or not they have a customer. Does that make sense? And it doesn't have to make 100% sense me explaining it, but do you kind of get the concept of why we would use inner versus a left? Silence scares me.
It does.
Make sense.
Okay, perfect. Yeah, so basically just depending on what you want. And that's why it's important to know what the difference between left join and right join and inner join do. So another one, let's go through one more scenario. And this is one of my, I use these all the time because a lot of times we want to know, hey, which people don't have an address or which countries don't have customers. So that's a great scenario, right? Let's say we want to know which countries don't have a customer. So here we have our query here. And I'm just going to kind of reduce this down bare bones. So we're just going to get the country and we have all of our left joins. We want to find which countries, if any, don't have a customer. And this is, I like this guide because it kind of shows you. So really what we're looking for, which countries don't have customers? Well, it would be this one right here because we want everything from country. We don't want any matches because we're only looking for those who don't have a match. So we want to exclude all this over here. No overlap and obviously nothing from the right. So it's a left join, but then we have where b.key is null. And so we're just going to say where. And this is pretty simple. We want people who don't have a customer. Well, we're getting all the countries. So if customer ID is null, then we know it doesn't have a customer. So we do, which is interesting. We do have some countries that have 0 customers attached to them. So this is a good example of why we want to do that, because this whole work that I did up here would actually be, it's not incorrect, but it would be excluding some of these countries. And I don't know why we have duplicates, but we do. So let's just, there we go. All right, cool. So we do have some countries that do not have any customers attached to them. And we could find that by utilizing this left join. And we just say, hey, where customer ID is null, which countries don't have any. Oh, and you know where that came from? It's off of the city, probably, because that means we have a store there, but no customers in that country. Cool. Cool. All right. And obviously there's more kind of scenarios like, oh, I want stuff from both sides that don't match. Really what's nice, this looks more complicated than what it is, because your left join and right join are literally the same thing. It's all just on order. So like that way, if you want to just write it backwards, you can use a right join instead of a left join. So in concept, they work the same exact way. One just uses one side of the table, the other one uses the other. Then there's a full join, which is I want all the data no matter what. And then there's one that says I just want non-matches on either side. And then the one that they actually don't show here is a cross join. And what a cross join does is it multiplies the tables together, which is kind of complicated. So I'm going to make a fake table. So what I'm going to do is I'm just going to say select yes, or let's use dice, right? I'm going to select one. Let's just do that. If I select one, you'll see that it just kind of returns one, and I'm going to say as dice number. So now I have a dice number as 1. So what I'm going to do is I'm going to actually just kind of fabricate a table real quick. Union. Let's copy this because we're going to use it a lot. Let's say 2. 3. 4. 5. 6. All right. So there's our dice number. And what we might want to do is, let's say, so we have our dice number here. Let's say that we want to, let's actually, I'm going to rename this. Sorry. Let's, can I do this here? I'm going to rename this to dice 1. And the reason I'm going to do this, because if we wanted to really quickly figure out the total possible combinations of dice rolls using a different number of dice, we can do so pretty easy with some SQL. So we have this kind of here, which is kind of like a table. Now you can kind of see it. Dice 1 is going to be our thing. And we're just going to duplicate this, but call it dice 2. And let's say we wanted to build a table that has the different combinations of every possible roll using 2 dice. We could do that. And the way we do it is with a cross join. And I don't think that was going to work, but we were going to try it. So what we're going to do is we're going to say select every, we're going to select, yeah, let's select everything. We're just going to make these kind of act like tables. That's probably why it didn't work. Call that one dice 1, and we're going to cross join. Dice 2. And there we go. You can see that we multiplied it. And let's order this so it makes some sense. Order by 1. All right. So basically what the cross join does, you'll notice it doesn't have an on clause because it doesn't matter. Because we literally take every row from table A and we multiply it by table B, which is called a Cartesian product. And basically what we get is every possible combination. So for dice 1, we have, row 1. If the number's 1, we get 1 1 1 2 1 3 1 4 1 5 1 6, and so on and so forth to get every possible combination. So that's what cross join does. It's really handy for when you're kind of fabricating data. Like in this case, if I want to figure, what are the total roles that could possibly be there, like we could let's select dice 1, dice 2, and then we want the sum, or no, not the sum. We just want dice 1 plus dice 2. Because the sum will aggregate, but we just want to add the rows together, the 2 columns together as result. And there we go. We have every possible outcome and roll combo for 2 dice. So that one's nice. It's also nice when you're doing dates. Like if I want to say, oh, I'm creating a record for every day in 2021, you can cross join certain things to the day and make it kind of neat. Anyways, we've gone over 15 minutes. Does anyone have any join specific questions?
The one you just did, is that an implicative or expressive cross join? I'm just looking at old notes from previous class.
Say that one more time. What kind of join?
Okay, so there's a cross join where you use expressive syntax and then there's an implicative syntax. So I'm assuming what you're using, it looks like a expressive syntax, but I just wanted to confirm.
Correct. Yeah, I'd have to go back and look. But yeah, I'm pretty sure. Yeah. Yep. Yeah, I know it's yeah, I'm pretty sure that's correct because this is the ANSI 92 version. Because alternatively, because instead of saying cross join, we could just say join and get the same outcome. And that is the ANSI 89 syntax, which is the older way of doing things. Now you can kind of specify what the join is in the join and make sure that it's the right one.
Thank you. And the reason why I'm asking is just trying to come up with more information to put in the paper this week, because you're asking about joins on ASCII SQL 92 for the paper.
Okay, perfect. And I'm glad you brought that up because let's real quick go over that. So let's show you ANSI 89 and then I'll show you ANSI 92. So ANSI 89, this is the old way of doing it. So let's use our same customer to address thing going on here. And we're just going to go from customer to address for the sake of time. So let's select everything and we're just going to get C dot last name and A dot address. All right, so this is kind of what we did before. We just want the last name let's get their first name too, I guess, so we can. There we go. So we have last name, first name, and address. So in ANSI 89, they didn't have inner join, they didn't have left join, they didn't have that kind of stuff. They just had join, or alternatively, you could just use a comma. So I'm going to show you the comma version, just because I think it's the most foreign compared to what we're used to. So if I try to run this, you'll notice that it throws an error, and it's actually throwing the error on the on clause. And so in ANSI 89, they didn't have an on clause. You had to do everything in the where clause. So in this case, we would say where C dot customer ID is equal to C dot address ID is equal to A dot address ID. And we have our results. So you kind of had to do it all manually. And why did we switch? I guess let me show you ANSI 92 before we get too crazy, which we're used to seeing, but we're going to interjoin that. And instead of it being a where clause, it's going to be an on clause. So between these two, these are actually the exact same query. One is just the old way and one's the new way. This is the new way. But the reason why they switched is a fundamental efficiency reason. And I'm going to walk you through it because I think it's really important. So when you run a SQL query, there's a certain order that the computer kind of operates on it. And I'll walk you through that. So the first thing that it does is it evaluates the from clause. And when we say the from clause, that includes all the join conditions. So the first thing that the computer does when it looks at your SQL statement is it says, which tables am I getting this data from? So in ANSI 89, it goes and it gets all the data from customer C and address A, and it loads both those tables into memory or into RAM. And then the next thing that the SQL statement does is it runs your where clause, because realistically, the first thing we want to do is exclude as much rows as we can to free up those computer resources. So in this case, then it would go through and it would check each row to match, and then it could exclude them. So let's say we go from 1 million to less, because if we run this all by itself, as we showed before, we actually get Cartesian product. So in ANSI 89, when we first run this, we load table A times table B into RAM. So we multiply our data. So let's say that table A has 1 million rows and table B has 1 million rows. Well, now we have 1 million times 1 million. And you can imagine that that's a lot of space. That's a lot of RAM. In fact, I've run into this issue recently. I had a little tiny server that only had 2 gigs of RAM, and I was running a select statement on it, and it would actually kill the server because it ran out of RAM, because it was loading both the tables into memory. So I had to then optimize my query. So in this case, ANSI 89, it's going to multiply everything and then filter it out based on the where clause. So it takes every possible combination, and then it says, okay, which ones match? So it kind of does it like the hard way. It says, okay, I'm going to build every possible combination and take out the ones that I don't want. So it's inefficient. What they do in ANSI 92 is, since this is all built into the from clause, it kind of does it smart as it goes about it. So it actually loads these tables up while it's kind of filtering them out. So basically what it does is it says, hey, I'm going to load all the data from customer C, and I'm only going to load the data from address A. And you know, this is the hidden secret of databases, but it's going to, it's way more efficient because it matches as it loads the data, if you will. It filters out any necessary, it doesn't duplicate every possible combination. So I'm glad you asked, because that's what ANSI 89 looks like. This is what ANSI 92 looks like. you need to be aware of ANSI 89, especially if you're taking a certification exam. But ANSI 92, I've actually never written ANSI 89 because I think it's horrendous, it's gross, and it's inefficient. So I wouldn't spend too much time like making sure that you can write it just as efficiently as ANSI 92. But you might want to know like, oh, you can do this. That way, if you see a question that has a comma in it, you can kind of know like, oh, this is doing a cross join. And the where clause is where I'm going to be checking for my matches. So thank you for asking that. I'm glad you brought that up because I would have missed that. Great question. All right. Well, since we've now gone almost a half hour over, thanks everybody for coming. If you have any questions, feel free to reach out, and good luck this week.
Thank you.
Thanks.